Here are some best practices for peer reviews. Most importantly, formal reviews, generally in the form of Fagan-style inspections, optimize the number of bugs found per dollar. That means they not only find more bugs than informal reviews, but they find them more efficiently. Your project planning should target 5 to 10% of the total project effort and should expect to find half to 2/3 of the defects with that effort. That's a great bargain, since testing often takes half the cost of the project and lets many bugs slip past. Those peer review meetings sounded kind of cumbersome, so you might be asking, how is it that they're cheap? The intuitive answer is that a reviewer can review 100 times faster than a developer can write code. Typical productivity on an embedded system project is only about 1 or 2 lines of code per hour all in from end to end. But a reviewer can review 100 to 200 lines of code per hour, as we saw. So even with 3 reviewers, you're coming out way ahead in terms of review productivity compared to writing the code. It's only about 5 or 10% of the project cost, including test effort. Make sure you review everything that is written down, not just the code. This will find the majority of defects before the code is even written because you're reviewing things before you write code. That will reduce cost and reduce schedule uncertainty. Use a checklist and perspective-based reviews to find the most bugs. The biggest pitfall in peer reviews is that engineering intuition thinks that informal reviews work fine. This is just incorrect. A way to measure this is to take enough data from reviews to see if they're finding more than half the defects. Generally, they should find about 2/3 of the defects. What we've seen is that informal reviews usually find less than half the defects, and in fact, usually find less than 10% of the defects. That means the reviews are broken. Most engineers are familiar with and live by the 80-20 rule, and in most cases, that intuition serves them well. In this case, it doesn't work out. Engineering intuition might make you think that a review that's only, say, 20% as formal as a Fagan inspection should find 80% of the defects. But that's just not the case. Generally, informal peer reviews find very few defects. Once you go formal, you find not only more defects, but you find more defects per dollar spent doing reviews. Sure, doing some peer reviews is better than doing no reviews, and you will find some defects. But the compelling payback is just not there until you get to quite formal in-person review meetings. Another pitfall is that you cannot wait till the end of the project and then expect to do all your peer reviews. They're cheap, but they're not free. And worse, if you try and bunch them at the end of the project, you're just going to burn out your reviewers. You should probably only be doing 1 peer review per day. And that means you can't wait to the last minute and do all of them. A better, more sustainable approach is to schedule the peer reviews regularly. For example, say 2 or 3 peer reviews every week as the project progresses. Then just keep a queue of things that need to be reviewed. Next time a review comes up on the schedule, pull something off the queue, do the review. One last point to discuss is review tools. There are several online review tools. Many of them are okay, but they should not be considered a substitute for formal in-person reviews. In-person reviews provide intangible benefits, such as mentoring newer team members, level setting on software quality culture, and providing peer pressure to enforce focus on close scrutiny of the code rather than just casual read-throughs. Finally, static analysis tools such as PCLint and compiler warnings are great ways to find defects in code. These should be done before the review to avoid wasting human time finding things a machine can find. But they are no substitute for an actual in-person, formal, checklist-based peer review or inspection.